Alright guys, we made it to the last video of chapter 5. It's going to be a double lesson again. Talking about similar figures. So a similar figure is when we have the same shape but different size. So they must be the same exact shape, just a different size. Our fundamental property of similar figures: if two figures are similar, then ratios of corresponding lengths are equal. The first thing you have to be very careful about is making sure that you match up the correct size. So which side of triangle XYZ corresponds to the given side of triangle ABC? So we could check by just looking. I have triangle XYZ compared to triangle ABC. By going through that, I see that they are in the same order. Neither triangles have been flipped or turned or anything like that, so I can use my pictures this time. So side AC, I see is over here, that's my bottom line, so that's going to match up with side XZ. Now you must write the line above it, that shows that it's line segment XZ. Then line segment BC or side BC. And if you look at our picture, that's the side on the right. So it will also be the side on the right. So side BC matches side YZ. Again with the line on top. Make sure you have your line on top. If you don't have that, we would have to mark you wrong, because now you're not talking about a line segment. And last but not least, side AB would match up with side XY. Now, if they had not been given in the same order, so if one of those triangles was flipped and you can't quite flip it in your mind, you can match them up. So I see XY comes first, so that would match up with AB because they come first. Then I see YZ are my last two, so BC are my last two. Or I could go X to Z, skipping the one in the middle, would match with A to C, again skipping the one in the middle. So two different ways you should match them up there. But again, it's important that you match the sides first. All right, we're told that the figures are similar. So I want to find the missing measure. So I'm looking for my X. Right, there's my X, that's the side I'm looking for. Now notice these little part circles in our angles. What this tells us: one line matches up with one line, two matches up with two lines, and then three would correspond with the corner or vertice that has three. Again, we see that they're in the same order this time, so we can just go from side to side. So we want to set up a proportion. So my 4 centimeters would match up with my 12 centimeters, so 4 over 12 equals. Now since I started my numerator in that triangle, I also have to have my numerator from this triangle on the other side. So 6 would match up with my X. And just like always, we're going to cross multiply. So 4 times X, 4X equals 12 times 6, which is 72. Divide both sides by 4. And we get that X equals 72 divided by 4 is 18. Go back to the triangles, they were labeled centimeters. So 18 centimeters. Now we can also use similar figures like that, setting up a proportion, in order to do indirect measurement. So indirect measurement is where we don't actually measure the distance that we're looking for. We use another similar figure to find the distance. So the example given: use the measurements at the right to find the height h of the flagpole. Use a proportion. So we see that when this flagpole that we don't know the height of makes a 72-foot shadow, a 3-foot ruler would make a 5-foot shadow. So matching up our sides, 3 feet would correspond with our missing height. So then 3 is in the same figure as 5. So a 5-foot shadow was made when our flagpole made a 72-foot shadow. Again, matching them up. So this came from one figure. I'm sorry. This was a corresponding side. This was a corresponding side. Going across our smaller figure in our numerator, larger figure in the denominator. Again, there are different ways that you could have set this up, but they must match going across. And as always, proportion, cross multiply. So 5 times h gives us 5h equals 3 times 72, which is 216. Divide by the number with your variable. Make sure you show it on both sides. And h equals 216 divided by 5, which is 43.2. Go back to our figure. We're talking about feet. All right, now that we have gone through a few examples, let's give you guys a shot. First example, the figures are similar. Find each missing side. So here's a missing side right there. Make sure you set up a proportion, show your work. And the second one, an indirect measurement. At the same time, a 12-foot adult elephant casts a 4.8-foot shadow. A baby elephant casts a 2-foot shadow. We want to know how tall the baby elephant is. All right? It's the end of chapter 5.